In previous videos, we talked about how to solve systems of equations and how to solve systems by graphing. In this video, we will introduce a method of solving systems of equations using an algebraic method, substitution. I'm using this example, which is the exact same example we used when we solved by graphing. So to refresh your memory, we solved this system of equations earlier by graphing. The strategy was to graph the first line all by itself, right here in red, and then the second line on the same coordinate plane, right here, which I did in green. When we solve a system of equations, we're looking for all possible points that satisfy both of the equations. Graphically, that's represented by wherever the graphs of the equations intersect. So since they intersect right here, this would be the solution, and it happens to be at the point 2, 1. What we're going to do is we're going to find a way to find that point, 2, 1, without having to use the graphing method, which will have a couple of advantages, as we will see in a moment. One of the first and most obvious advantages is that you don't have to actually get out graph paper and set up a graph and graph so precisely. Everything will be done using algebra. So let's take a look at this system. We're solving using substitution, and the strategy here is to get one of the variables all by itself alone on one side of one of the equations. In other words, solve for one of the variables. Now, this system of equations is really nice for substitution because both equations are already solved for y. We know what y equals in the first equation, and we know what y equals in the second equation. So since we've already solved for one of the variables, that's done for us. All that remains for us to do is actually substitute. So what I'm going to do is I'm going to say that y equals 2x minus 3. And I know that from this first equation here. Now it's a good idea to, once you've solved for one of the variables, put the expression in parentheses. This will come into play when you have to distribute, when you substitute in, or some other possibilities as well. So it's just always a good idea to put the expression that you are going to be substituting in parentheses. Now that I've used that first equation to express y, I'm now going to use the second equation. Y equals negative 3x plus 7. And I'm going to use this equation to solve for x after I substitute in for y. So I know what y equals, so I'm going to substitute in for y. Y equals 2x minus 3. So I'm going to rewrite this equation, but instead of writing any of the y's, I'm going to write this instead. So y equals 2x minus 3. And then I just continue writing the rest of that equation. In this case, we'll notice that the parentheses won't make any difference right here, so we can just rewrite this equation, and I'm going to change subtraction to addition by adding the opposite in order to simplify both expressions. So since both expressions are simplified, step 1 in solving an equation is complete. The next thing that we should do is try to get the variable in one expression. We're noticing that the x is in both expressions, so I need to manipulate the equation in order to get x to one expression. I'm going to add the opposite of negative 3x to both expressions. In other words, I'm adding 3x to both sides. 2x plus 3x is 5x. Still have the plus negative 3. These go to 0, so that's going to equal 7. Continue solving. Now I need to get my variable alone by first getting rid of all terms without my variable in it. So I'm going to add the opposite of negative 3 to both expressions. That's going to give me 5x equals 7 plus 3 is 10. And last, I multiply both expressions by the reciprocal of the coefficient. That'll leave me with x equals 5 goes into itself once and into 10 twice. We'll have x equals 2. Now, take a look at the original problem. We're trying to solve this system using substitution. Well, how many variables are in this system? There's an x and there's a y. There are 2 variables in this system. We're not done once we've found the first variable. So don't circle this and say, I'm finished, I found out what x equals. You're looking for one variable when you solve an equation, but when you solve a system, you need more than one variable. We don't just need the x, we also have to find the y. So that's the next step. The next step now will be to find y. Since I now have a definitive value for x, I can substitute that into any of these equations in order to find y. So I'm going to go ahead and pick this first equation, and I'm simply going to rewrite it here. Y equals 2x minus 3. Now, since I know exactly what x equals 2, I'm going to substitute that value into x here. So this is going to be y equals 2 times x equals 2 minus 3. And I'm going to change subtraction to addition by adding the opposite. And continue simplifying. 2 times 2 is 4. And so y equals 4 plus negative 3 is 1. So I now know that x equals 2 and y equals 1. I found both of the variables. Remember, when you're solving a system, you need to find all of the variables, which I have done. As we discussed in the video for solving by graphing, you can list your solution in one of 3 ways. You can either list them as simply the ordered pair, x equals 2, y equals 1. You can list them as a solution set, or you can list them as another system written in a more simplified form. So we have the x should equal 2, and y equals 1. So either one of these 3 ways is an acceptable way to write the solution. Notice that this solution is the exact same solution that we found when we solved the same problem using the graphing method. We found that x would equal 2 and y would equal 1. So both methods of solving will give you the same solution. They're just 2 different ways of getting to the same answer, to the same solution. Let's take a look at a second example of solving a system of equations using substitution. Remember, whenever we're going to substitute, we need to solve for one of the variables. We need to get one of the variables alone. It doesn't matter which one you get alone. You can pick whichever one will be easiest. In the last example, both equations were already solved for y, so we didn't have to worry about this first step. However, when you look at this example, neither of the equations say either x equals or y equals, so that means we're going to have to transform one of the equations in order to achieve that. You have your option of transforming either equation. It's recommended, though, that you look at the equation to try to figure out which one will be easier. And in this instance, since this expression of the equation has only one term and it has an x in it, it would be one step in order to solve for x. So let's go ahead and first solve for x. Now you can solve for x or solve for y. Doesn't matter which one you solve for first, but try to pick the one that's going to make your life easiest. I'm going to solve for x, and I'm going to use the first equation. 3x equals 9y plus 6. To get x by itself, I need to multiply both expressions by the reciprocal of the coefficient. And since there are terms in the right-hand expression, I need to get it in parentheses so that I distribute the 1/3 to both terms. This will leave me with x equals, when I distribute the 1/3 to the first term, I'm going to skip a step here. If you would like to write the steps in to see exactly what's going on here, you may. But this is going to be 3y plus 1/3 times 6 is 2. So all I've done here is distributed 1/3 to the 9y, so it's 1/3 times 9y, which gives me 3y, and 1/3 times 6, which gives me 2. Now I found out what x equals. X equals 3y plus 2. So now that I've solved for x, I can find y. In order to find y, I need to use the other equation, the equation that I didn't solve for x in. So I'm going to start with that equation, 2x plus 3y equals 7. There are two variables in this equation. However, if I use the value that I found for x, or if I use the expression that I found for x, and substitute in, then watch what will happen. I will end up with 2, and then I'm going to substitute in this expression for x, which is 3y plus 2. And then I'm going to continue to write the rest of that equation, plus 3y equals 7. Notice now that there is only one variable in this equation. I can now solve for that variable, which is y. Now, notice that I'm multiplying 2 by x, and since x has terms in it, in order for this to come out correctly, I have to distribute the 2. When I simplify both expressions first, I'll need to distribute the 2 to both of these terms here. That's why it's so important to make sure that you get your variable in parentheses, like I did over here, so that when you substitute it in, you know when you have to distribute. So I multiply 2 by 3y, that's going to give me 6y, plus 2 times 2 is going to give me 4. Bring down the plus 3y equals 7. I can still simplify, I can combine these like terms. 6y plus 3y is 9y. Still have a plus 4 equals 7. Now I can continue solving here. Need to get rid of terms without my variable in it by adding the opposite. This will give me 9y equals 3. And now I multiply both expressions by the reciprocal of the coefficient, which is 1/9. That'll give me y equals 1/3. So I now know that y equals 1/3. From here, I can now find what x is actually equal to. I can find x. And I'm going to use the same expression here. X equals 3y plus 2. I'm just going to substitute in the y equals 1/3. So I'm going to substitute in for y where I found in the other equation here. This is going to give me x equals 3 times y is 1/3 plus 2. 3 times 1/3. 3 goes into itself once and into itself once. This is going to be 1 times 1 over 1 times 1. That's going to simplify to 1. So this is going to be x equals 1 plus 2, or x equals 3. Remember, whenever you're solving a system of equations, you must find both an x and a y. Don't think that once you found out what y is that you're done. You still have to find x, like we did over here. So now we can put these together in an answer. We found that x equals 3 and y equals 1/3. This is the ordered pair that will satisfy both of these equations. And let's go ahead and plug it into this first one here just to make sure that it works. I'll leave the check on the second one to you. X equals 3, y equals 1/3. So let's check it. 3 times x equals 9 times y plus 6. Alright, so I just copied this first equation right over here, except I left a blank for the x and the y. X equals 3, y equals 1/3. Three times 3 is 9. 9 times 1/3 is 3. And the left-hand side is simplified. 3 plus 6 is 9. Sure enough, we got a true equation. 9 equals 9. So we have just proven that the ordered pair that we found satisfies the first equation. I will leave it to you to prove that it satisfies the second equation. Also notice that in this solution, one of the values is not a whole number. It's a fractional value. This is one advantage to solving using substitution that's better than solving by graphing. Remember, when we solved by graphing, we took this as an example, and here we had to estimate this solution here. We estimated that it was about 4 3/10, 4 6/10. We didn't know the exact values though. Notice that when we solved using this method, algebraically we know that the y value is exactly 1/3.